Okay, we're going to go ahead and do some longhand division. Now, we're eventually going to be doing longhand division with polynomials, but we're going to just start out with some normal numbers to begin with. Now, if we're doing longhand division and using no calculator, we're going to do longhand division on 4 into 85. So we'll put 85 on the inside of your half box and put the 4 in front. And then we have to ask ourselves, how many times does 4 go into that first number? 4 goes in there twice, so I'll put a 2 on top. And then we've got to take the 2 times the 4, and that gives us 8. And that tells me what to put here. Now, we go ahead and now subtract. 8 minus 8 is 0, which I don't have to write. I bring down the next term on my 5, and then I repeat the process. It's a very iterative process. So 4 times what is 5? Well, nothing exactly, but 4 goes into 5 once, so I'll put a 1 up here. Take my 1 times my 4, and that gives me 4. And then I'll go ahead and subtract. 5 minus 4 is 1. Now 4 doesn't go into 1. There's nothing more I can bring down, so this is my remainder. So my answer is 21 plus my remainder over my divisor. The remainder of 1 over my divisor of 4. Now if it just asks to find the quotient in the remainder, you go 21 comma 1. But if it just says divide, you should probably write it like this. Now most people would write just 21 and 1/4, but it really means 21 plus an additional fourth. So if we were dealing with longhand division on this, we're going to really start out the same way. We're going to take our trinomial, put it inside the half box, and just like what we did before with the last problem, we went, okay, in the last problem, we went 4 times what is 8. So I'm going to go my x times what is x squared. Well, x times what is x squared? That's an x. So I'm going to put an x up here. Just like in the last problem, how did we figure out this 8 underneath? We took what was in front times what we put on top. So we're going to take what we have in front, x minus 5, times what we put on top of x. So x times each one of these, x times x is x squared. X times the negative 5 is negative 5x. Now we're going to go ahead, and normally we would subtract. And that's not too hard to do with this one. But when you start getting into lots of negatives and you're subtracting, sometimes that messes people up. But remember, instead of subtracting, you can just add the opposite. So I'm going to switch all my signs, and then I'm going to add. So I'm adding the opposite. So I'll add my x's down, x squareds, and they're going to drop. Negative 2 to the x plus 5x is this here. Then I'm going to just bring down my negative 15, and then it's an iterative process, so I just repeat. I look at what's in front here, which is x, and go x times what is my 3x. And in this case, that's just a positive 3, so I'll put a positive 3 on top. Take that positive 3 times everything in front, so positive 3 times my x, positive 3 times my negative 5. Then, instead of subtracting, I'm going to just switch the signs and add. So, when I add 3x plus a negative 3x, that drops and gives me 0. Negative 15 plus 15 is 0. So in other words, I get a remainder of 0, so that means I really have a factor because it goes in there nice and evenly. So when I go ahead and divide these, I end up getting my 3x, or x plus 3, remainder 0. So if the directions were asking for the quotient and remainder, you would write this. Now, if it asks for you to just go ahead and divide, you'd put your quotient down, then you go plus your remainder over your divisor. Now, being 0 over this, we probably won't really need it, so you could just write this here. But in general, if you would have a remainder, you're going to take it over your divisor. That's longhand division. So go ahead and maybe try to do this one here on your own. But be aware that you need to set it up correctly. Here you're missing some terms. you're missing your cubed, your squared, and your x to the first. So you need to put zeros in there as placeholders. Then go ahead and try this one on your own. So x squared times what is x to the fourth? Well, that's an x squared, so I'll put that there. Take x squared times each thing in front, and take x squared, distribute it through, times everything in front. We get this here. Then you want to go ahead and switch all your signs, and then just add down. Well, when you add down, the first term should always drop. 0 of these plus negative 3 of these. 0 of these plus negative 1 of these. Bring down your next term, and then repeat. X squared times what is negative 3x cubed? Well, that's just a negative 3x. So take that negative 3x times all three things here in front, and it tells you what to put down below. Then we switch our signs and add. So we switch our signs. Negative 3 of these plus 3 of these, they drop out. Negative 1 of these plus 9 of these is 8 of these. 0 of these plus 3 of these is 3 of these. Bring down your next term and repeat. So we need to think x squared times what is 8x squared? Well, that's just a plus 8. So I'll take 8, multiply it by all three of these, tells me what to put underneath. Then switch my signs and add down. The first terms drop. 3 of the x's plus a negative 24 of the x's is negative 21 of the x's. Negative 16 plus a negative 8 is negative 24. Now x squared doesn't go into a normal x, so we're done, and this is our remainder. So if it was asking for the quotient remainder, you'd write this, comma, this. If it said to go ahead and just divide, you're going to write your quotient here, plus, you're going to then, after your plus sign, you're going to go a fraction with this being your remainder on top, and this being your, this being your quotient on the bottom. We also have synthetic division. Synthetic division, some people find easier. However, synthetic does not always work. Synthetic only works if this is your variable to the first power plus or minus a number. So you can't have anything in front of it, and your exponent has to be 1. So in other words, it would not have worked in this one here, because we weren't dividing by an x to the first here. We were dividing by an x squared. So longhand division was the only way to do that last one. Now we've already done this problem with longhand, but let's go ahead and do it with synthetic. So you need to start off by looking at what it is you're dividing by. You want to set this equal to 0, so x minus what is 5. No, sorry, x minus 5, set equal to 0, solve it for x, and we get 5. So that's going to go in this little half box. What goes to the right of the half box is just the numbers, your coefficients, and your constant. So coefficients are the numbers in front of your variables. Your constant is here. We have a 1 in front of our squared. We have a negative 2 in front of our x. And then we would have our constant of negative 15. Now remember, just like with longhand, if you were missing any terms, you'd have to put zeros in here as placeholders. Now with synthetic, we only do two things. We add and multiply. 1 plus what's underneath of it, which is nothing, is 1. Now we multiply the 5 times the 1, and that's 5. And then we repeat and we add. We add down, we get 3. Then we got to multiply, and that tells us what to put here. And then we add down. Now, this last number is our remainder. What we have right here is our quotient. So in this case, our remainder is 0. Now, we initially had an x squared divided by an x. Well, x squared over x is an x to the first. So we have a 1 x to the first, and then this would be our constant, because when you're writing it in standard form, the next thing below your x to the first is your term that has no x's. And that matches with what we had back here. So let's go ahead and try to do synthetic here. You notice we're not missing any terms. We don't need to put zeros in as placeholders. We want to set this equal to 0 and solve it, and we get 2. That tells us what to put in that half box. Then we take all of our coefficients followed by a constant and put them afterwards. We don't put plus, we don't put subtraction signs, but we do include our negatives, and we don't include the variables. And then once again, all we do is add and multiply. We add down, multiply, tells us what to put here. We add down. Now we have to multiply the 2 times the negative 2. It tells us what to put here. Then we add down. And then we continue to repeat. We multiply and tells us what to put here. Then we add down. The last one is always your remainder. What's before is always your quotient. So in this case, our remainder is 0. Now we had an x cubed divided by an x to the first. Well, x cubed over x to the first is an x squared. So this is an x squared here, so we'd have a 1x squared. This would be the next lower power. Well, that would just be an x to the first. So we have a negative 2 of the x's. And then this would be the next lower power, which would be x to the 0, or just your constant. Now, if you're dividing by a monomial, meaning one term, it's easier just to go ahead and write it as separate fractions. So take this over your denominator, take this over your denominator, take this over your denominator. Because remember, if you were just adding fractions, you'd have to have the same denominator, and then you could write it as one big fraction. Well, you can do the reverse process. Take each thing on top over your denominator, and you get this. Now all we have to do is simplify. X's drop. Which one has more y's, top or the bottom? The top does, so we just get a 6y. Here, x's and y's both drop, so we just get a -3. Here, our x's are going to drop, one of them, leaving us 1 on the top, and our y's are going to drop. And so we get a plus a 2x. Now this problem here could have also been written like this, because remember, if you have a negative exponent, you'd have to move it down to the bottom, and it would look like that.